Section 11.1. When a straight line and a circle lie on the same plane, there are three possible cases. Case 1. The line does not intersect the circle, which means the number of intersection points is 0. Case 2. The line touches the circle at only one point. And touches, this word is very important, which means the number of intersection points is 1, only 1. Case 3. The line intersects the circle at 2 points, which means the number of intersection points is 2. In this chapter, we focus on case 2. A straight line which touches a circle at only one point is called a tangent to the circle. This is tangent. The point where the line touches the circle is called the point of contact. This. As you can see, the yellow line is tangent, and the green point P is the point of contact. Property 1. If I have a tangent here, AB, and the point of contact P is here, we all know that OP is the radius. Then we will have a property that this angle is 90 degrees. When we use this property, write down tangent is perpendicular to radius. With example 1. The main point of this question is diameter and tangent. AP is a tangent. We can use the yellow line represent tangent, so we can see very easily. Since CP is diameter, then we have OP is the radius, and then we have this angle equals 90 degrees. Because tangent is perpendicular to radius. As we have learned before, the angle at center twice angle at circumference. And then we have this angle equals 40 degrees. And in the triangle APC, by the sum of triangle, this angle can be calculated like this. And the property 2 is the converse of property 1, which means now I have a straight line APB. This is only a straight line. I don't know whether it is tangent or not. Perhaps the line is like this. A is here, P is here, and B is here, and there is another point, Q, which is very close to P. Then it is not a tangent. So we cannot just say a straight line is a tangent by observation. We must use a property. In this property, we only know OP is radius, and there is an angle of 90 degrees. And then we can make a conclusion. This straight line is tangent, because this is converse of tangent is perpendicular to radius. With example 2, the question is, AP is tangent to the circle or not? In the figure, OP is the radius. If angle OPA is 90 degrees, then PA is tangent. If angle OPA is not 90 degrees, then PA is not tangent. Okay, let's find out. Since OP and OQ are ready, triangle OPQ is an isosceles triangle. Then angle OPQ equals 30 degrees. And then angle OPA is 30 degrees plus 60 degrees. Then we have 90 degrees. And we may write down like this. Property 3. This time I know APB is tangent. And this angle QPB is 90 degrees. Then we know the center is somewhere along this straight line PQ. Okay, along this straight line. And you should write down when you use this property. Example 3. Okay, keywords. Tangent. Use the yellow color represent the tangent. We know this is tangent and we have 90 degrees here. So the center is somewhere along this straight line PQ. Okay, we mark it somewhere here. Okay, it makes sense. PQ passes through the center. Then PQ is diameter. And it is 28 cm. Then we have the radius is half of it. Okay. Property 4 is very important. In this property, we have an external point T. And we can draw two tangents from T. After we draw the figure like this, we have two triangles which are congruent. So we have three properties. First one, TP equals TQ. The second one, angle TOP equals angle TOQ. And the last one, angle OTP equals angle OTQ. And we have to write down tangents from external points when we use this property. Example 4. Keywords. TATB are tangents. And we draw the tangents by color of yellow. Tangents from external points, we have TA equals TB. So triangle TAB is an isosceles triangle. Then angle TAB is equal to 65 degrees. And the angle we are going to find is angle ATB here. We can find it by using sum of triangle. Then we can write down like this. Example 5. Keywords. There are two tangents. T touch at A and B. And we have to find angle BTO first. We mark the tangents by using color of yellow, and these are tangents. Tangents from external point. We have two congruent triangles here. Then this angle equals 25 degrees. We can write down like this. And then we move on to find the angle BOT. This angle. Tangent is perpendicular to radius, so we have this angle 90 degrees. By using sum of triangle, we can calculate angle BOT like this. Okay. Example 6. Okay, keywords: two tangents from T touch at A and B respectively. Then we mark the tangents like this. Okay. We are asked to find angle AOT. This angle AOT here. First of all, we may use adjacent angle on straight line here, because here is a straight line 125 degrees, and then we have this angle 55 degrees. Two tangents make congruent triangles. Then this angle AOT equals 55 degrees here. And you can do the homework now.